Let us now solve some problems on Floyd's algorithm. So Floyd's algorithm basically is used to find the minimum cost spanning tree. Okay, so in Warshall's algorithm, the same technique was used, but in that we only use that algorithm to find the path where only 1 0 was there. But in this thing, here we will be actually finding the path. So in this given question, we have a graph like this. So basically, 4 node graph is there. So 1, 4, 3, 2. So it is a directed graph. So 4 to 1 it is 1, and 1 to 4 is 1, and 4 to 2 is 2, then 4 to 3 is 9, 2 to 3 1, and 1 to 2 is 8. Okay, then another path we have which is from 3 to 1 directly, which is 4. Okay, so now let me write the formula for this. So d of ij of k, so it's similar itself, is equals to minimum of, so here we have d of ij of k minus 1, that is nothing but the previous value which it was actually having. If it is minus, then it will be by default 0 or infinity, or else, so it will be same. So here d of ik plus d of kj, and here it will be k minus 1, k minus 1. Okay, so for k greater than equal to 1, so d of 0 is equals to w of ij. So okay, so this thing is for k greater than equal to 1. Okay, why? Because k of 0 will be initially it will always generate the same, because we cannot take minus 1. So if we have d of 0 of ij, because which is less than 1, so it is always equals to w of ij. W of ij is nothing but the actual weight. So suppose from 1 to 4 it was 1, so d of 0 if you are doing, so 1 to 4 will be like the actual weight itself. So now this is the formula. While solving, I will be explaining the formula and writing one by one each step here. So now first let me write my r naught here. R naught is nothing but, so I have to draw this graph 1 2 3 4 1 2, not graph, matrix 1 2 3 4. So now 1 to 1, so always note that diagonal matrix will be 0. So this is a cost matrix, not a path matrix. Okay, so Warshall's is a path matrix, and Floyd's is a cost matrix. Okay, so in questions they sometimes they will only mention dynamic programming. So if they have mentioned any path, so they have asked for path, then you have to go for Warshall's. If they have mentioned for cost, minimum cost, then you have to go for Floyd itself. Okay, so 1 to 2 is 8, 1 to 3 infinity, 1 to 4 it is 1. Okay, so let me just write it infinity, here it is 1, infinity, infinity, infinity. 4 to 3 is 9, 4 to 2 is 2, and 4 to 1 is infinity, 3 to 1 is 4. Okay, so this is my initial r naught. So now here at the first place, if I consider 1 to 1, so no, we have to take this and then compare with the help of this when it is 1, right. So with the help of this row and this column, I will try to find wherever it is infinity. Okay, so I will just erase this because I do not require this over here. So let me just put it like this. So now I have to find R1. Okay, so R1 is equals to, so now see here, I will draw the same matrix once again, and then I will just erase wherever the changes are happening. So 0 infinity, 4 infinity, 8 infinity, 1 0 1 infinity, infinity 0 infinity, 2 9 0 1 2 3 4. Okay, so now here my k is 1. Okay, k equals to 1 according to this. So now one thing I want to say is you just see here, from each node to each node you just try to find out or figure it out which is the smallest cost. Okay, so from, if I have to go to 1 to 4, it is only 1, and if I have to go to 1 to 2, it is 1 plus 2, that is 3, and here if I have to go to 1 to 3, so it is 1 2 1, that is 4. Okay, so from 1 I have visited to 3 places in all the other nodes in the most minimum place. So just write it somewhere and keep it. Okay, so such that, okay, so let me just write it for my reference. So 1 to 1 should be 0. So 1 to 2 should be 3, 1 to 3 should be 4, and 1 to 4 is 1. So I have to find my answer in such a way that at the end I might change and I should get this kind of result. So now see here. So now let me take 2. 2 to 1 is infinity. If I have to reach 1, so how can I reach? So 2, it goes only from 3, from 3 4, so it is 5. Okay. Then now 2 to 4, how to go to 2 to 4? I cannot go in either way. So if I go to 1, 1 plus 1 to 4, so 2 to 3, 3 to 1, 1 to 4, so that is not 1 plus 1 plus 4, that is 6. Okay, 2 to 4 is 6. Okay, so 2 to 3 is 1 and 2 to 2 will be 0. So 3 to 1 is 4, that is the minimum thing. 3 to 2 I have to go it in such a way, 4 plus 1 plus 2, so that will be 4 plus 3 is 7. Okay, then its diagonal is 0, then 3 to 4 it will be 5. Okay, at the last 4 to 1 I can go for 2, 3 and then 1. Okay, so 2, 1 again 4, so it will be 7. So this will be similarly 3 to 2. If I have to go, sorry, 4 to 2 is 2 and 4 to 3 will be 3, 2, 1. So and 4 to 4 0. So this you just write in pencil and keep it somewhere. Why? Because this is our this thing. Okay, so only try to find places in such a way that this thing will help you. Okay, so now see here, I will take this one first. So my k is 1. Okay, so now what I will do? So 2 to 4, right? This is 2 to 4. So now I will do 2 to 1 plus 1 to 4. So 2 to 1, it is infinity. So this thing here also if we gave infinity, so there won't be any changes in this. Now I will consider this wala infinity, that is 3 2, 3 comma 2. So 3 to 1 plus 1 to 2. Okay, so 3 to 1 is 4 and 1 to 2 is 8. So 8 plus 4 gives us 12. So I have to select minimum of infinity comma 12. So it's 12 is greater, so it will become 12 here. Okay. Now similarly, if I try to find this infinity, usually they skip the first this thing. Why? Because we won't be getting the actual optimal solution. So they directly start from the second one. But still, just for experience sake, I am doing this. So 3 4. So here it will be 4, and here it will be 4. So 3 to 1 is still okay. So 3 to 1, 3 to 1 is 4 itself, and 1 to 4 is 1. So it's 5. So this thing I got it as 5. Okay. So now that's it. Other things I cannot change now. I have to consider the other matrix. Okay. So I got R naught was here, and then I got R1. Okay. You just note it down here. Now I'll erase this. So better let write it here. So 0 8 infinity 1 infinity 0 1 infinity 4 infinity 0 infinity infinity 2 9 0. Okay, so this was my R0, and my R1 is this. I am writing here now. That is 0 infinity 4 infinity 8 0 12 2 infinity 1 0 9 5 sorry 0 5 infinity 1. I am not doing the naming and all. Why? Because it will take just way time consuming. Anyhow, I am writing here, right? So now with the help of R1 I will find this R2. Okay, so let me write it same, then I will make the changes. So 0 infinity 4 infinity 8 0 12 2 infinity 1 0 9 1 infinity 5 0. So 1 2 3 4 1 2 3 4. So I am considering this row and this column. Okay, so now I will try to find this. So I am doing 1 3 1 comma 3. okay, 1 comma 3. So k is 2, right? Now k is 2. 1 to 2 plus 2 to 3. What is 1 to 2? That is 8. 8 plus 2 to 3. So 2 to 3 is 1. So I got 9. So this thing I will change it to 9. And each time when you do, keep an eye over here. So whichever value you have changed, at the end try to change that value. So since I got this, I won't be doing any changes over here. This is the least one. So now this one I change. So I'll try to change this now, 4 1. Okay. So this is 4 comma 1 now. So my I is 4 and my j is 1. So 4 to 2. 4 to 2 is 2 plus 2 to 1 is infinity. So it will be infinity itself. Okay. So it won't give anything. So this thing will remain as it is. Done. So this is my R2. Okay. So yeah, that is my R2. Now I'll just write it here. So 0, infinity, 4, infinity, 8, 0, 12, 2. So this changes to 9, 1, 1, infinity, 0, 5, 9, 0. Okay. Now I will be considering this part. So now see here, this has to be 3 and here it is 8. So I will try to solve it and I will check whether it will help or not. So k is 3 now. So 1 comma 2, right? So 1 to 3 plus 3 to 2. So 1 to 3 is 9. So see here itself it is 9, right? So no need to go here. So 1 to 3 it's actually too much for us to visit. So I won't consider that. Okay, let me solve for this infinity place. So it is 2 1. So 2 comma 1. So I will be like 2 to 3 plus 3 to 1. I have to go. So 2 to 3 is 1 and 3 to 1 is 4. It gives me 5. So this thing will become 5. So as you can see here also it has to be 5. So from pictorial view itself we got to know where which should be there. Here it is 12, right? So I have to change it also in such a way. Now let me try to find 4 1. Okay, 4 comma 1. So 4 to 3 plus 3 to 1. Okay, so 4 to 3 is 9 plus 3 to 1 is 4. It gives me 13. So is it correct what I am doing? 4 to 3 is 9 plus 3 to 1, it is 4. So 4 to 1, this will be 13 here. Again at the last place I have to do changes in such a way that it will reduce and generate me some value. So as you can see here, this one and this one we have got the proper value, and even this one. So yeah, now I'll write my, so this was my R2. Yeah, so my R3 is equals to, so now I got my this matrix. So now what I will do, I will remove this and I will consider this. So let me write it again itself. 13, 8, 0, 12, 2, 9, 1, 0, 9, 1, infinity 5, 0. So I have to consider this. Okay, this I will erase, same, right? So now see, I will try to get. So is there any infinity? No, infinity here not there, but still I will try to minimize this one now. Okay, let me try now. So here my k is 4. Okay, so this is 1 2 3 4, 1 2 3 4. So 1 2. So 1 to 4 plus 4 to 1. Okay, sorry, 4 to 2. So 1 to 4 is 1 and 4 to 2 is 2, which gives me 3. So see here I got it as 3. even let me, so this also let me try, that is nothing but 1 3. So it will be like 1 to 4 plus 4 to 3, which is 1 to 4 1 plus 4 to 3 9. So here it's giving me 10. So actually it had to be 4. So here in the previous places, if we had made it as 3 somehow, so how can we make it as 3? So this place is like 4 comma 3, right? 4 to 3. So with the help of second vertex itself, we could have done that. That is nothing but here in R now. So with the help of this, we could have tried to go there. Still we will try to like take further steps and make it simple. Okay. So with the help of second node, we could have actually done that. So when we were having this 2, but I guess at that time we didn't have the other values. So suppose if you had taken here, let me do it from in the pencil. So we wanted this, right? So if I had considered this and this, okay, so let me just draw it. It's not visible, I know, but still. So if I had to consider this, so it will be 4 to, oh sorry, this I had to consider like this. So 4 to 4 comma 3. So 4 to 2 is 2 plus 2 to 3 is 1. So actually we could have done it in the first place itself, which is nothing but when we took this, right? So let me just show you here. It's 0 5 4 13 and 3 0 12 2, and also see here 4 to 1 is 7. So how will I get that after I make it as this as 3? Wait, so first let me just show you one small changes here. 1 infinity 5 0. So here when I consider like this, so if I have to take this, so it will be like 4 to 3, right? So sorry, here 4 to 3, so I can take 4 to 2 plus 2 to 3. 4 to 2 is 2 plus 2 to 3 is 1, so it will give me 3. Okay, so I can make it as 3 itself in this place here itself. So here it will be 3. Okay. So now if this was 3, then in the same place if I have to make this 4 1, so if let me try here 4 to 2 plus 2 to 1. So 4 to 2 is 2 plus 2 1. So here itself it will become 7. So I forgot to like see here and try to solve it. Sorry for that. So here it is 7. But anyways, like I said, whatever here you just make one reference, according to that you will be making. Okay. So since okay, so only this thing. So just check if we have to change things. So now let us come to this 1 3. Okay. 1 to 4 plus 4 to 3. 1 to 4 is 1 and plus 4 to 3 is 3, which gives me 4. So this will change to 4 now. Okay. Then anything else? So this one. So this is 12. It should be 7 actually. How we know it's 7? Because from the diagram itself we know which will be the shortest part for 3 to 2. So this is 3 2. So it will be 3 to 4 plus 4 to 2. 3 to 4 is 5 plus 4 to 2 is 2, which gives me 7. So this will also become 7 now. Okay. So now I got my R4 matrix. So now from R4, now what I'll do, I'll consider this first again. Why? Because I still have an infinity here. 0 3 4 1 5 0 1 infinity 4 7 0 5 7 2 3 0. Okay. So now see here, I'll consider this row again. Okay, 1 2 3 4 1 2 3 4. So now what I will do, so this I k and k j, right? So I have to find the infinity, that is 2 comma 4. So 2 to 1 plus 1 to 4. So 2 to 1 is 5 and 5 to 1 to 4 is 1. So sorry, this is, yeah, so it gives me 6. So now see here, it is the same as this. So I can conclude here itself that my final cost matrix is this, which is nothing but the same which we had analyzed from this graph and written here. So in the middle I just missed one place, but you can actually but I corrected it again. So you can see like this and solve any problem if they have given. The graph will change sometimes, it may not change sometimes, but remember, first see from this thing which is the shortest path. Okay, so I'll just try to highlight also once here. You see last. So from each node we have to find a path how to go here. So for 1 to 4 direct is there, 1 to 2 direct is there. So 1 to 3 is not there. So among these two, which is a short, 1 2 1. So you got like that. So the same way for everything, you just find and write in the pencil. Then one by one keep solving and check if you can change the same way, and then you go to the last step and then just finish it. So this is nothing the one easy, like not easy but just a problem to solve in Floyds. Remember the algorithm also, learn it. They might ask with or without algorithm. Okay, sometimes they might ask only problem, sometimes they might not ask the problem. So make sure you prepare yourself properly and then you go, because it will be helpful in lab program also, right? So if you learn the lab program also, you can write the inner part of code where this thing will work. So that for loops are itself enough as some algorithm.